We're starting with the 13-1 textbook rectangle class that we did last week in class. We're using the 3-file version, which is now in public in class shares, if you would like to use it. We started off with the main program. We had created a rectangle type object called box, and then we got the width and the length. We used mutators to set the width in the private variables, and then we used accessors to get the width back to display out to the user. In the rectangle class, we had 2 privates of length and width, and then a set of accessors and mutators. I didn't put section comments on those, did I? Well. All right. I'll do better next time. And then these were just copied right out of the book. We transferred it from the 1-file version with the additional code. Some of these are so short that you'll see in my pet class, what I did was put them all on one line because they're so short. In a CPP file, but all on one line, just so we got to practice. Well, let's then create we're doing overloaded operators first. Let's say that we want to create a copy constructor to enable us to set one object equal to another object. And so what we're going to do is go back to our rectangle. We didn't even put any constructors in here yet, did we? So let's, the constructors are added if you don't put them. I don't even have any in my little cheat sheet either. Well, let's put one in. Let's make a rectangle constructor. You tell me how to make a rectangle constructor. Let's assume that we have one that gets nothing. Anybody like that? Oh, capital letter R. And then shall we go, Blake, are you typing the whole thing over? Oh, okay. And then let's go over to the CPP file and let's stick a constructor up there. And what happens when we go to the CPP file? What do we have to add? Scope resolution operator. So that would be the class, and then the 2 colons. And then here we're just going to set everything to 0 because we'll use a set width operator to do it. The computer made this for us. This is the default constructor. If we don't make it, the computer makes it for us. So we'll say that width equals 0 and length equals 0. I put them all on one line. Is that horrible? And we're going to add a copy. We're going to add an overloaded equals sign. Oh, the get area. Okay. So let's go back then, and Chapter 14 has the overloaded operators. That's in section 14.5. 14.5. We saw last week, just on a quick skim through, that you can overload the prefix operator. You can overload the postfix operator That's page 832. But if you do that, you have to add a dummy parameter in there. Prefix is fine. Postfix takes a dummy parameter. And then you can overload the relational operators and the greater than and less than and the C in and C out and the array, the square brackets for the array. And then you can actually change an object type as well, do an object conversion, which is technically in the next section, but it's kind of the same. Chris was asking me about that, actually. So let's see. If we wanted to say whether the area of box 1 and the area of box 2 were equal, let's say we wanted to do that, then what we would want to do is create an overloaded operator for that, and we could do a, that's a, I'm adding stuff to the end every time just for my convenience. And when you do your test, I'll be looking for things in the whatever's in the .h file to be in the same order as it appears in the .cpp file. I mean, there's no rule about that, but just good coding practice. So anyway, let's look on page, where's the overloaded equal sign? Tell me which page it's on. There's an example here of an overloaded equals. Should I put it on pause until I find it? Alt W for wait, right? Overloaded, greater than, less than, prefix, 19. 19? Okay. 819 starts the equal sign. Okay, let's see if we can find ourselves some code to copy from, right? Don't it reinvent the wheel? Test scores.h. I'm looking for the header file for it. Under what page? 820? I was looking for the overloaded operate. Well, it's on page 821 is the overloaded equals. So. That one's not the equals though. Let's go back and see that's an overloaded plus and an overloaded minus. Let's just go back to 821 there. What'd you say? Yeah, it kind of continues on and off over a couple of pages. Oh, I'm recording? I wonder if it didn't pause. Oh, sorry, makes you watch all that much? Oh, well. Here. Skip. Let me skip to here. There, how's that? So when you're watching, you can skip the beginning part. Okay. I wonder if I have to set those hotkeys every time. Oh, I'll try it later. Okay, let's say that we want to have an overloaded equal sign, and this will be an overloaded equals to compare two objects. So this is going to be, I got to do the function prototype first. Let me add a function prototype. And if you look on page 821, right in the center, it's going to say, it's going to be of return type void because it's just going to do a comparison. Now, if you had a greater than or less than, it's going to return a bool, right? That's what comparative operators do. relational operators do, but this is an equal. So it's return type void, and then it's strange, but the way you indicate that you're overloading an operator is to write the word operator and then put which one. You can put a space or not. I kind of squeeze it right up against so I don't forget what I'm doing. And then you have your parameters. So we're not going to change either of the originals, so we'll put const. And then we're going to have what class is this? Of a rectangle class. And when you use these overloaded operators, you need to work with the original. So of class rectangle by reference. I meant I was supposed to set the hotkey before I started. Yeah, it's okay. All right, now we can go copy this prototype and stick it over in the CPP code down at the end there. And you know, we copied over from the .h to the .cpp, so now we'll have to add of class rectangle scope resolution operator. There we go. Okay. Now we need to give this thing a name. You can call it anything, of course, but the book introduces you to a concept of calling it right because it's going to compare the one on the left with the one on the right. And so what you're importing is the one that will be on the right. That's your argument to compare them. Not required, but sounds logical to me. And then what our comparison is going to be is we're not comparing. I'm sorry. I'm setting, this is part of my, oh boy, I told you the wrong thing. This is setting one object equal to another object. It's like a copy constructor, except we're using an overloaded operator. Okay. So what I want to do is into this object that I'm on, I'm going to, into that width member, I'm going to put the value of whatever was in that right object I got, their width. And then into my private length member, put whatever object I got on the right length. Is this font big enough to see on the video Caleb had watched? Or do I need to crank, or, I'm sorry, Brandon? I could crank it up one more notch. Think it was fine? I didn't think to check. Let me go up to 17. I think that should be good for sure. I can always zoom in, but if you're copying, no, that would be better. Okay. Now we could do a greater than and a less than, but, you know, write them in the opposite order, all right? Let's make one to compare whether one box is greater than the other box, like the area of it, for example. So that's a relational operator, and it takes a bool as a return type because it returns a true or false. So this would be a return type bool, and it will be operator greater than, operator greater than, and the argument's going to be the same. And by reference. That discussion about calling it right is at the bottom of 821, by the way. Of course, if anybody listens to this video next year, it'll be a different page, but that's close. It's after the contents of the student test scores version 3 and before the textbook program 14-6. Okay, the question was, why would this greater than operator return a bool? Because, what did it say it again? Because you can't, it's an overloaded operator because this is not a num or a float or a double, it's an object. And so a greater than sign doesn't know how to do something with an object. So you have to teach the computer how to do it. Boy, I'm glad you asked that question. It's a good question. Well, that was good. I got nothing useful out of that copy and paste. So now we'll go finish defining it. Overloaded greater than to see if one object is larger than another. That was a really good question, Matt. Okay, this is of class rectangle. No, no, no. What'd I do wrong? I have what? Bool, and then the class name. Okay. And then we'll say, well, we'll have to make a return bool variable. We have to make one to return. So let's make a bool called, I don't know, status. Okay. And then what we'll say is if the length is greater, if the length of, we see it's 2 greater than 1. So if the length of the, we're comparing areas, not just length. Okay, let me put that in here. Comparing areas of 2 rectangles to see which is larger. Okay. We could have written any number of things, but we'll say if the one's bigger than the other, then return a true, else return a false. All right. So if, when you do width times length to get the area, if width times length on the current, on this object, the one on left, is greater than the length times width on the right object, whatever one you're comparing against. So right dot width times right dot length. If that's true, then status equals true. If, or, well, I guess else status equals false, right? Well, I suppose you could check to see if they're equal. But you don't have to check it because if it's not greater than, that's all we ask for. We didn't have an overload greater than or equals to, then we'd have to do 2 checks. We're just checking greater than. So. And then we'll return the status. So that's what I had sent out about the pet project. I was trying to think of some overloaded operator. If you had 2 pets, you could, oh, I guess you could The pet age is still a num. What could you make for an overloaded operator on the pet? Somebody think of something and let me know. Chris was trying to think of something. He was doing legs and feet or something, but I couldn't make it into. Yeah. All right. So let's then hop over to the main, and then here's the rectangle data. What we're going to have to do is modify this so we have two boxes. All right. So let's make a. We made a. Where's box dot one? Rectangle box. Set the width rectangle. Okay. So let's make and set second box. So we'll say of type rectangle, of class rectangle, make an object, instantiate an object called box 2, and then into box 2 put the private variables of box 1. Well, that's all there is to that. And I don't know. I'm just going to put it right here. That's all together. Then we can say, oh, we'll have to make a function. We could say if, I'm sorry? Oh, it's just box? Okay. If box is greater than box 2, then see out box 1 has a greater area. God bless you. That's kind of a boring statement. We better add some more to that, huh? Oh, box, yeah. Box. But we can, let's make sure this much runs first, huh? Question? Yeah, but we'll change it here in a second. Do a little at a time, make sure it runs. Yeah, I sure did forget the semicolon in the wrong place. Okay. Oh, now what's it mad about? Doesn't like my constructor, huh? There's no return type on a constructor. It's a class. What are you mad about? Here, let me put it on pause for a second while I fight with... It's an undeclared first use because you have to name your variable, initialize it when you're doing that. Let's see if it works now. Well, it's still mad. Rectangle previously defined here. Oh, yep, I sure do. Thank you. It's still mad. On the .h rectangle.h, when I give the prototype for the constructor, you don't put the curly braces there. You just, you don't define it in line. We didn't do that. I just wrote the prototype, so there's no curly braces there. So that's why that was mad. Okay. Multiple definition of rectangle. It was mad at me. I went up to execute rebuild all, and then it was fine. So I'll put in a length and a width, whatever. And then I didn't have an else statement on my cout, did I? So of course it's not going to say anything. Let's have an else. Else cout. They are the same or opposite. I don't know. That's not a good statement, but whatever. Now we'll run it. They are the same or opposite, so my line came out. That's what I wanted. Now then, as um, was correctly stated, when I make box 2 equal to box 1, which does a good job of testing the, the equals, they're always going to be the same. So let's do the same thing again. Let's reset it. Let's say to the box 2 object, do the set width function and send it. I'm going to hard code it. 5. And to the box 2 set length. Oh, I need to make those small. Make the other numbers. I want box 1 to be bigger than box 2. So these should be small numbers and box 1 will be bigger numbers. Okay. Yep, thank you. Is that going to be right now? Otherwise? So the first one, let's say, is 5 and 5. And so now we have box 1 has greater area. I'm going to just comment out this part. We don't need it right now. That other output statement. So that's how the overloaded operators work. And the trick is you have to think, if I were using num or ints or doubles or floats, then how would I use those and how do I need to use them in my object, and then whichever ones you need, you write overloaded operators to do those things to an object. But in my greater than, I did have to calculate the area first. I'm going to stop this one because we're going to start all over again with the cube.